Welcome back to the deep dive. Today we're actually doing something a little bit different.
Yeah, quite a bit different from our usual stuff.
Right. Usually we're looking at macro market trends or, dissecting a specific company's quarterly earnings. But today I actually want to talk about real estate.
Real estate.
Specifically the most expensive, the most technically complex, and honestly the most controversial piece of real estate you will ever own.
You are talking about the car.
I am. But not, the car is a machine that just gets you from A to B. I am looking at this massive stack of reports we have on the desk today.
And it is a heavy stack.
It really is.
Yeah.
We have got technical roadmaps from Qualcomm, architectural white papers from NVIDIA, software strategy reports from Electrobit, and some really deep market analysis on both the Chinese and European sectors.
Right.
And reading through them, they're all basically shouting the exact same thing. The distinction between your digital life and your physical drive is, well, it is about to completely evaporate.
It is the concept of the third living space.
The third living space.
Exactly. You have your home, that is one. You have your office, that is two. And now, arguably, for the very first time in a truly meaningful way, you have the vehicle as the third.
Right.
And looking at these documents, I mean, this isn't just marketing fluff from the automakers. We are looking at a fundamental engineering shift happening right now, targeting the 2026 model year.
And that is the exact premise we are working with today.
Mm.
For you listening, we are going to conduct a top-down strategic deep dive into this smart cockpit revolution.
Because it really is a revolution.
It is. And our mission here is to deconstruct how we get from, basic Bluetooth connectivity to a literal high-performance supercomputer on wheels. Because for a long time, smart in a car just meant what? That you could plug your phone in?
Yeah, maybe run a basic map app, that was it. But for the automakers today, this is the absolute new battleground.
It has to be.
It is. It is no longer about horsepower. It is not about cornering speed or 0 to 60 times. It is about building brand moats based entirely on digital experience.
Brand moats. I like that term.
Right. It is about massive profit margins derived from software, not hardware. Honestly, for a lot of these legacy automakers, it is simply about survival.
Okay, so to keep us from getting totally lost in the weeds here, because looking at this NVIDIA white paper, this tech gets incredibly dense very fast.
It gets extremely technical.
Yeah. So we are going to take a very structured approach. As a product strategy expert, I know you love a good MECE breakdown.
I do. Mutually exclusive, collectively exhaustive. It is the only way to analyze a shift this big.
Exactly. So we are breaking this down into 3 distinct, non-overlapping layers. First, we will look at the hardware foundation.
Section 8.1 in the source material, the cockpit architecture, the skeleton, and the brain.
Right. Second, we look at the software ecosystem. Section 8.2, the eye, or the soul of the machine.
The services, the apps, the money.
Exactly, the money. And third, we are going to look at the interaction layer. Section 8.3, the HMI, which is how we, as fragile human beings, actually talk to this supercomputer.
Hardware, software, interaction. It is a clean structure.
Let's start right at the bottom of the stack then. Section 8.1, the cockpit, the hardware foundation.
Let's dive in.
Okay, so reading through these Qualcomm and NVIDIA reports, the absolute biggest headline here, the strategic shift, seems to be this idea of unification.
Unification is the exact key word, but to really grasp why that is a big deal, we have to look at the problem they are fixing.
Okay, paint the picture.
If you look at a car from, say, 2020, even a luxury car, the computing architecture was just a complete mess of distributed systems.
Distributed meaning scattered all over the car.
Yes. You had a specific, weak little chip just for the driver's dashboard, a totally different chip for the center radio,
Okay.
another chip running the heads-up display, maybe 2 more separate chips for the backseat screens.
And these are all separate physical boxes.
Yeah, they are called electronic control units, or ECUs, and they were all trying to talk to each other through literal miles of heavy copper wire, the wiring harness.
Miles of wire.
It is often the third heaviest component in the entire vehicle. It was incredibly heavy, very expensive to manufacture, and most importantly for this 2026 vision, it was just too slow.
Too much latency.
Exactly. The latency between a sensor seeing a pedestrian and the dashboard screen actually drawing a warning box around that pedestrian, it was too high. The data was bottlenecked.
So the industry is fixing this bottleneck with what exactly?
The unified cabin concept. The industry has aggressively moved to what they call cross-domain fusion.
Cross-domain fusion.
Right. We are talking about utilizing a single, incredibly powerful system on chip and SoC. And this one chip runs absolutely everything.
Just one chip to rule them all.
Essentially, yes, it completely eliminates all those scattered ECUs. And the tech titans fighting for dominance in the specific space are exactly who you would expect.
Qualcomm and NVIDIA.
Yes. But reading the reports, they actually have slightly different strategic philosophies on how to build this brain.
Let's look at Qualcomm first, because I was reading the specs for their Snapdragon Cockpit Elite, and I think it's the Gen 5.
That is the one.
And honestly, it reads like a spec sheet for a high-end home theater system, not a car part.
Well, they are playing to their historical strengths, right? Qualcomm comes from the mobile and multimedia world, so this Gen 5 chip, it natively supports up to 16 different 4K displays simultaneously.
I have to pause you right there. 16 displays in one single car. That sounds like absolute overkill. Where are you even putting 16 screens?
It sounds excessive until you apply that third living space concept. Let's count them out.
Please do.
You have the main driver instrument cluster behind the wheel. That is one. You have the massive center infotainment screen. Two.
Sure, standard stuff.
Then you have a dedicated passenger entertainment screen, so the person in the shotgun seat can watch movies without distracting the driver. That is 3.
Okay.
2 large rear seat entertainment screens. 5, maybe individual climate control touchscreens in the door handles. An interactive touchscreen embedded in the rear armrest. Add in digital rear view mirrors, external displays for pedestrians, and the augmented reality heads-up display. You get to 16 very quickly.
Okay, when you actually list it out like that, it is an astonishing amount of glass.
It is, and Qualcomm is heavily banking on this consumption experience. They are bringing actual gaming-level graphics, specifically ray tracing, right into the dashboard.
Ray tracing. We are talking about the ultra-realistic lighting rendering tech used in, like, high-end gaming PCs.
Exactly that. Real-time lighting, dynamic reflections, perfect shadows.
But why? I mean, it's not just so you can play high-end video games in the back seat, right?
I mean, you definitely can do that. But strategically, it is about the user interface itself. They want the digital buttons on the screen to look and reflect light like physical premium jewelry.
I see.
They want the 3D navigation map to look like a photorealistic drone feed of the city you're driving through. It makes the digital interface feel doubly physical and expensive.
So Qualcomm is really pushing the visual and consumption experience. But looking at the NVIDIA papers, particularly on their Drive Thor platform, they seem to be pushing something else. They're pushing the raw muscle.
That is a great way to put it. NVIDIA is taking a pure supercomputer approach. This Thor chip, it offers 2,000 TOPS.
Break that acronym down for us. TOPS.
Trillions of operations per second.
Trillions.
Yes. For some context, a really good premium laptop right now might do 10 or 20 TOPS.
And this card chip does 2,000.
Exactly. And their strategy is fundamentally different from just running 16 screens. They want to run the cockpit, the infotainment, the movies, the maps, and the automated driving systems, the ADAS, all on the exact same physical chip.
Wait a second. So the exact same computer brain that is, say, rendering my 3D map and playing my Spotify playlist is also the brain deciding when to slam on the brakes at a crosswalk.
Yes. That is the ultimate goal of cross-domain fusion, unifying the convenience domain with the critical safety domain.
I am going to be honest, that seems incredibly risky. I mean, my smartphone crashes. My laptop freezes all the time. If my car's infotainment system freezes because my kids are playing a heavy video game in the back, does my autopilot crash too? Do I just lose my brakes?
That right there is the billion-dollar engineering question. And the answer is why these 2026 architectures are so revolutionary. The secret sauce isn't just the hardware speed. It is extreme virtualization.
Extreme virtualization. Explain how that works in this context.
So on this single massive physical chip, the engineers install a foundational layer of software called a hypervisor.
A hypervisor, like QNX or the open source ACRN.
Exactly. Think of the hypervisor as a very strict landlord of a building. It builds impenetrable virtual walls inside the chip itself. It divides the computing power into distinct, isolated rooms.
Okay, I like the apartment building analogy. So who lives in these different rooms?
Well, in one apartment, let's call it the massive penthouse suite, you have the open world.
The open...
Yes. This is where your Android Automotive OS lives. This is where Netflix runs, where Spotify streams, where the 3D video games happen.
It is a high-performance, chaotic environment.
Exactly. It is highly complex, constantly updating, and therefore it is inherently risky. Apps in the penthouse can and will crash.
Right, because consumer software is buggy.
But then, downstairs, secured behind a digital steel-reinforced vault door, you have another tenant, the functional safety island. or FSI.
The safety island.
This is a dedicated, completely isolated section of the chip. It often has its own separate physical power supply routing and its own internal hardware clock.
Wow.
And it runs a highly stable real-time operating system. This tenant is strictly in charge of the brakes, the steering column, the speedometer, and the emergency warning lights.
So just to be crystal clear, even if the penthouse is completely on fire, even if the Android system gives me a massive frozen screen because I'm trying to stream 2 4K movies while rendering a 3D map, the safety island is totally unaffected.
Precisely. The speedometer on your dash will keep ticking perfectly, the automatic emergency brakes will still engage, and the hazard lights will flash.
That is incredibly clever engineering.
It is called mixed criticality architecture,
Wow.
and strategically, it is the only way OEMs can safely deploy consumer-grade, fast-updating software into a vehicle without violating the extremely strict automotive-grade safety laws, like the ASIL standards.
It is like having a wild frat party in the penthouse, but a secret service bunker in the basement that actually controls the building's life support.
That is a perfect analogy, but here is the physical catch. Because these unified chips are doing so much heavy lifting, running the hypervisor, running 16 screens, running complex AI models locally, processing radar data, they generate an immense amount of physical heat.
Which computers hate.
Exactly. And we are seeing a major shift in automotive engineering here. Simple cooling fans just aren't enough anymore.
Just because fans are too noisy for a luxury car.
Noisy, yes, but mostly they're just physically inefficient at removing that kind of thermal load. If you put a fan capable of cooling 2000 TOPS inside a dashboard, it would sound like a hairdryer.
Not exactly a premium third living space experience.
No. So liquid cooling is rapidly becoming the absolute standard for these high-end smart cockpits.
Liquid cooling, like you would see in a custom high-performance PC gaming rig.
Yes, but integrated at the vehicle level. They are literally plumbing the cockpit chip's cooling loop directly into the massive thermal management system of the EV's main battery pack.
That is a total convergence of consumer electronics and heavy automotive engineering.
It is, but there is one more critical strategic layer to this hardware story. The reports mention that leading OEMs, specifically General Motors, but also a lot of the incredibly fast-moving emerging Chinese brands, they are aggressively shifting towards an own platform strategy.
An own platform strategy. What exactly does that mean in this context?
It means they are refusing to just buy a generic off-the-shelf software solution from a tier 1 supplier anymore. They don't just want the hardware, they want to own the digital soul of the car.
So they are building their own custom operating systems on top of these hypervisors.
Exactly. Millions of lines of custom code.
Why? Is it just an ego thing?
Yeah.
About having total control?
It is about data. And data is money. If you completely control the base platform, you have absolute unhindered access to all the user data, where they drive, what they listen to, how stressed they are.
Right.
And if you control that platform, you control the gateway for subscription revenue later on. If an automaker just slaps generic Android Auto onto their screens, Google owns the customer relationship. Google gets the data.
And the automaker just becomes a hardware vendor?
Exactly. General Motors wants to own the customer. They want that recurring software revenue.
Which is actually the perfect segue into the next layer of our MECE breakdown.
Yeah.
We have built this incredibly powerful, liquid-cooled supercomputer hardware foundation.
Section 8.1 is solid.
Now, let's talk about the software ecosystem that actually runs on top of it. Section 8.2, the in-vehicle infotainment.
Though, honestly, looking at the trajectory in these reports, the word infotainment feels totally obsolete.
It really does. The industry seems to be pivoting hard away from just entertainment. The focus now is on productivity and the ecosystem. The cockpit is transitioning from a simple display interface into a highly active productivity hub.
Yes. The big strategic concept here is the mobile office.
Now, to be fair, we have heard automakers promise the mobile office for, what, a decade? Check your email from the driver's seat. It was always terrible.
It was terrible because it was just a mirrored phone app. But the 2026 vision is fundamentally different.
How is it different this time?
Deep cloud integration. The car itself is now acting as a secure native node on the enterprise cloud. We are seeing incredibly deep native integration with ecosystems like Microsoft 365 and Microsoft Teams, built directly into the car's operating system.
Okay, so the car itself logs me into the morning conference call.
The car essentially is the conference room. Imagine an onboard AI agent that silently listens to the meeting while you navigate traffic and then generates a bulleted summary of action items on your HUD when you're parked.
That is actually useful.
But here is the really fascinating part, and this is a massive strategic point highlighted in the Electrobit report. It is called the cross-domain safety interlock.
Unpack that term for us. Cross-domain safety interlock.
Okay. Remember how we just talked about the safety island and cross-domain fusion?
Right, the infotainment and the driving safety systems sharing the same chip.
Because they share that chip, they can talk to each other instantly. The car now has holistic context.
Context about what?
About you. The car knows you are currently engaged in an active Microsoft Teams video call. It knows, therefore, that your cognitive load is currently very high.
Because I am distracted by my boss talking on the screen.
Exactly. The car knows you are cognitively distracted.
So what does the car actually do with that information?
Automatically, dynamically, and without you ever pushing a button, the system reaches across the domain and actively increases the sensitivity of the ADS.
Wait, really?
Yes, it automatically increases your following distance for the adaptive cruise control. It makes the lane keep assist algorithm much more aggressive. It might even prep the brakes earlier.
That is brilliant.
It dynamically compensates for your lack of attention.
So it is active safety based on what I am doing inside the cabin, not just what the radar sees happening on the highway.
Exactly. It creates what they call a productivity bubble. It allows you to safely focus on work because the vehicle proactively takes on a much greater share of the actual driving burden.
That is a massive value proposition.
It is. Analysts project this AI-driven AD productivity market could reach 17 billion euros by 2030.
17 billion. That is why they want to own the platform. Now, speaking of devices, we have to talk about the smartphone's role in all this. For years, it felt like Apple CarPlay and Android Auto had basically won the dashboard war.
They certainly dominated the last generation.
But the sources here point to a totally new model emerging, primarily out of China. They call it smartphone as a domain.
Yes. This is heavily exemplified by the Flyme Auto model from Meizu and Geely. It is a complete philosophical shift.
How so?
Instead of just dumbly projecting your phone's screen onto the dashboard display, which is all old CarPlay really does, the car actually integrates with the phone at the hardware level. It borrows the phone's computing power.
It borrows the actual processing power from my phone in my pocket.
Yes. It is called computing resource sharing. Let's say the car's main chip is heavily burdened running a complex ADS simulation and managing the thermal systems.
Okay.
The car can literally offload non-critical background tasks like rendering a specific app or processing an audio stream over to your phone's Snapdragon chip if it detects it is connected and has spare capacity.
That is wild. So my personal phone becomes an active co-processor for my vehicle's network.
Correct. And the sharing goes both ways. It shares physical hardware too.
Give me an example of that hardware sharing.
Say you are streaming a large file on your phone, but your 5G connection is struggling because you are sitting inside a heavy metal box, the car.
A Faraday cage, essentially.
Right. The phone can seamlessly, wirelessly utilize the car's external shark fin antenna, which has massively higher gain and power to boost its own cellular signal.
That is incredibly clever resource management.
Or the reverse. If the car's built-in data plan is capped or out of network, the car can seamlessly route its telemetry data through your phone's 5G modem. It completely dissolves the barrier between portable devices and fixed automotive hardware.
And I assume this deep hardware integration is what finally enables that truly seamless handoff we've been promised for a decade.
Completely. Imagine you start a video call on your phone while walking across the parking lot.
Right.
You open the car door, you sit down, and the call instantly, with zero latency or fumbling with Bluetooth menus, snaps to the car's high-def screen and the surround sound speakers.
And what happens to the phone?
Your phone screen just goes dark, and the UI shifts to become a secondary controller. It becomes a dedicated mute button or a trackpad for the presentation.
That is the exact level of frictionless integration consumers actually want.
Yeah.
But there is a serious business side to this software layer too, isn't there? The reports call it the mall on wheels.
Oh, absolutely. This is the holy grail for automakers. This is where the massive recurring revenue comes in. The smart cockpit is actively becoming a highly secure cryptographic transaction node.
We are talking about in-vehicle payments.
Yes, but think way beyond just ordering a coffee from the dashboard screen. Think about smart fueling or autonomous charging.
How does that work in practice?
You pull up to a compatible charger, you plug the car in, and you just walk away. The car digitally authenticates itself with the charging station, verifies your pre-stored payment credentials on the secure enclave of the chip, and executes the payment.
No credit card swiping, no fumbling with 5 different charging apps on my phone in the rain.
Totally frictionless. The car is the wallet. And then there is the big one, feature on demand.
Oh boy. I feel like this is where a lot of listeners are going to get annoyed. This is the whole subscription for heated seats debate, isn't it?
It is highly controversial, yes. Consumers historically hate it. But look at it strategically from the third living space perspective.
Defend the model for me.
Okay. Say you lease a standard sedan. It is great for your daily city commute, but you are planning a massive weekend trip up to the snowy mountains.
Okay.
Through the dashboard interface, you can dynamically purchase a temporary subscription to an advanced off-road traction control algorithm or extra battery range just for that specific 48-hour window.
So I am essentially renting advanced physical capabilities for my car via software.
Exactly. The over-the-air software update unlocks the latent physical capability, securely charges your account via the car's payment node, and then locks the feature again on Monday morning when you are back in the city.
I can certainly see why the automakers are obsessed with this model. They aren't just selling you a hunk of metal once every 7 years. They're selling you highly profitable digital services for the entire lifetime of the vehicle.
Precisely. It completely transforms a one-time hardware transaction into a continuous, monetizable service relationship.
But to build all this complex software, the payment nodes, the deep office integration, the cross-domain safety protocols, the automakers fundamentally have to change how they build software, don't they?
Yes, and this is a massive operational shift. They are adopting virtual engineering.
This is the shift left concept mentioned heavily in the Electrobit reports.
Right. Shift left. In traditional automotive engineering, the waterfall method software teams had to wait for the physical silicon chips and the wiring harnesses to be physically manufactured before they could really test their code.
Which takes years.
It takes years. And it meant that by the time a new car finally rolled off the assembly line, the software inside it was already 3 years out of date.
Which is exactly why car infotainment systems always felt 5 years older than the iPhone in my pocket.
Exactly. So shift left means they move the software development timeline completely to the left side of the chart much earlier.
How do they do that without the hardware?
They create what is called a virtual ECU, a perfect digital twin of the future hardware, hosted entirely in the cloud on massive server farms like Amazon AWS or Microsoft Azure.
So the engineers are writing, compiling, and testing the car's software on a completely simulated virtual computer in the cloud.
Yes, sometimes 18 months before the physical chip is even stamped out of a silicon wafer in a factory.
That is incredible.
This approach allows automakers to finally develop at what we call smartphone speed. It aggressively compresses development cycles from 4 years down to maybe 18 months. It is the only strategic way they can keep pace with the consumer electronics industry.
Okay, so summarizing so far, we have the Unified Superbrain Hardware Foundation, Section 8.1.
Okay.
We have the highly connected, highly monetizable productivity ecosystem running on top of it, Section 8.2.
Check.
Now let's get to the final piece, the part the driver actually interacts with. Part 3 of our MECE structure, Section 8.3, HMI, the interaction layer.
This is arguably where the AI revolution becomes immediately tangible to the consumer. We are seeing a complete paradigm shift from command-based control over to agentic AI.
Command versus agent. Break that distinction down for me clearly.
The old way, the current way for most cars is command-based. You, the human, basically have to act like a computer programmer.
Right. You push a specific button or you use a rigid voice prompt like set cabin temperature to exactly 22 degrees.
Exactly. It is entirely binary. Specific input yields a specific output. If you use the wrong keyword, the system fails.
And the new way, agentic AI.
The new way is entirely intent-based. You don't give a command, you just speak naturally. You just say, you know, I am feeling a bit cold and honestly pretty stressed out today.
And the car actually understands what stressed means.
Yes, because it is utilizing an agentic AI powered by a large language model and LLM running locally. It doesn't just parse the words, it interprets the underlying human intent.
It infers context. Cold means I need heat. Stressed implies I need a calming environment.
Exactly. So based on that intent, the system generates a complex macro action across multiple domains.
What does that macro action look like?
It silently raises the ambient temperature to 22 degrees. It engages the heated steering wheel. But it also shifts the ambient LED lighting from a harsh blue to a soft, warm orange.
Wow.
It dynamically crossfades the audio to a relaxing acoustic playlist. It sets the seat massage function to a gentle, rolling setting. It acts as an intuitive butler anticipating your needs rather than a dumb switch waiting to be flipped.
That is a profound psychological shift in the cabin experience. It feels much less like operating a heavy machine and much more like communicating with a companion.
That is exactly the user experience they are targeting for the third living space. But to execute this seamlessly, you need massive computational power.
You mentioned earlier about running the LLM locally. Why is that so important? Why not just send the voice request to ChatGPT in the cloud?
Two critical reasons: latency and privacy.
Latency makes sense.
Right. You cannot say, I am stressed, wait 3.5 seconds for the audio to ping a server in California, process, and ping back before the lights change. That delay completely shatters the illusion of a smart companion.
It feels broken. And the privacy aspect.
Frankly, do you really want a live microphone transmitting your exact emotional state, your private cabin conversations, and your stress levels to a third-party server farm every time you drive?
Definitely not. That is a data privacy nightmare.
Exactly. This is precisely why those NPU neural processing unit specs we discussed in Section 8.1 are so critical. You need 30 or 40 TOPS purely dedicated to AI, just so the LLM can run securely on the edge, right there inside the physical car.
But there is an inherent risk with these LLMs, right? We see it all the time with text generators, hallucinations.
Yes, confidently stating incorrect facts.
Right. If I ask my smart car, hey, why is the red check engine light flashing? I do not want the AI to get creative. I don't want it to write me a beautiful poetic sonnet about engine combustion. I need the absolute mechanical truth.
You are exactly right. An AI hallucination in a driving context is incredibly dangerous. So, the engineering solution to this is RAG, Retrieval Augmented Generation.
RJAG. We hear that acronym a lot in tech circles right now, but how does it specifically apply to automotive safety?
Think of the conversational AI as a very smooth, very charismatic spokesperson. It sounds great, but it might improvise.
Okay.
But standing right behind that spokesperson is a strict, no-nonsense librarian. That librarian is the RAG architecture.
I really like the librarian analogy.
When you ask what is wrong with the engine, the charismatic AI immediately wants to generate a fluid conversational answer. But the librarian intervenes.
The RG system blocks it.
Yes. The RRAY system forces the AI to look exclusively at a locked, verified database, specifically the car's digital owner's manual and the real-time cryptographic sensor fault codes.
So it severely constrains the AI's knowledge base.
Exactly. The RJ system dictates you are only allowed to formulate an answer based entirely on these specific facts.
It checks the mechanical reality before it speaks.
Yes. It grounds the AI, so the voice output will sound perfectly natural, like a friend saying, "It looks like your secondary oxygen sensor is malfunctioning. I strongly suggest we pull over soon." But the core information is strictly, undeniably factual.
That makes total sense. It bridges the gap between natural conversation and engineering truth. Now let's talk about how the car communicates information back to us visually. We established in 8.1 that the screens are getting massive, but the reports heavily emphasize the rise of AR HUDs, augmented reality head-up displays.
This is a crucial safety evolution. It is all about cognitive load reduction.
Explain that.
Taking your eyes completely off the highway to look down at a 2D map on a center screen takes physical time.
Right, your eyes have to refocus.
Yes. But even worse, mentally translating a flat 2D line on a screen into a 3D physical turn in the real world that takes active brain power.
It does. Seeing turn left and 200 meters on a screen requires my brain to actively judge what 200 meters looks like at 60 miles an hour.
Exactly. With an AR HUD, the system utilizes lasers to paint dynamic, 3D holographic graphics directly onto the asphalt through the glass of the windshield.
So I don't look at a screen, I look through the data.
Yes. You see a glowing blue arrow hovering exactly over the lane you need to be in.
That sounds incredible.
And it is not just for navigation. Imagine driving at night and a pedestrian steps out from behind a parked van.
A nightmare scenario.
The car's thermal and radar sensors see them long before your eyes do. The AR HUD instantly highlights the pedestrian with a bright red tracking box directly in your real-world line of sight. It keeps your eyes up, focused out the window, exactly where they belong.
So the car is actively watching the outside world for me. But reading further into Section 8.3, the sources also make it clear that the car is constantly watching me.
It is. This is the concept of multimodal perception.
Multimodal, meaning combining different types of senses.
Exactly. It is the fusion of voice, gaze, and gesture tracking.
Give me a practical use case for that kind of fusion.
Okay. You are driving down a new street. You look out the passenger side window. You point your finger at a strange building. And you just ask out loud, what is that?
Just a vague question. What is that?
Yes. The system instantly tracks your pupil dilation and eye movement to determine exactly where your gaze is focused.
Okay.
It tracks the 3D spatial vector of your pointing finger to confirm the direction. It cross-references that exact physical vector with the high-definition GPS map data. And the voice assistant smoothly replies, that is the new modern art museum.
That is bordering on science fiction becoming reality.
It really is, but again, it also has a profound safety application. This is the DMS, the driver monitoring system.
Right.
High-precision infrared cameras inside the steering column are constantly tracking your eyelids, your blink rate, even micro-expressions in your facial muscles.
So you can definitively detect if I'm getting tired on a long drive.
It can definitively detect extreme fatigue long before you consciously realize you are tired.
That is powerful.
It can even detect the onset of road rage by analyzing muscle tension and heart rate variables. And because this interaction layer is deeply connected to that safety layer we discussed.
The cross-domain interlock.
Exactly. If the car determines you are having a medical emergency or falling asleep, it can actively intervene. It will gently tighten the seatbelt, pulse the brakes, engage the hazard lights, and autonomously pull the vehicle over to the shoulder safely.
That is incredibly reassuring from a safety standpoint. But honestly, it is also a little bit, I don't know, big brother, having a high-def infrared camera analyzing my facial tension for anger while I drive.
It is absolutely a privacy trade-off. And interestingly, this brings us to a major countertrend we are seeing right now, the phygital renaissance.
Phygital. Sizzle plus digital. I assume this is the industry pushback against the obsession with massive touchscreens.
It is. For a few years there, every automaker was essentially just copying the Tesla model. Delete all the buttons, put every single control onto a giant, flat iPad in the center.
Which looks very sleek and futuristic in a showroom.
It looks beautiful, but practically, ergonomically, we are seeing a strategic return to physical, tactile buttons. And this is being driven aggressively by regulatory bodies, specifically the Euro NCAP 2026 guidelines.
The European Safety Rating Agency.
Right. To achieve a 5-star safety rating in Europe starting in 2026, the guidelines mandate that highly critical vehicle functions, things like turn signals, hazard lights, windshield wipers, the SOS emergency call, they must be physical controls.
Good. Because trying to navigate 3 submenus on a flat glass touchscreen to turn on the wipers while you are hydroplaning in a thunderstorm is a literal nightmare. It is deeply unsafe.
Exactly. Or trying to find the hazard lights by touch alone when you have just been in a collision. You need muscle memory. You need physical feedback.
So are we just going back to the ugly, chunky plastic buttons from 2005?
No, the automakers don't want to ruin the premium aesthetic, so the engineering solution is smart surfaces utilizing piezoelectric haptics.
Piezoelectric haptics. How does that technology actually work?
Visually, the dashboard looks like a completely smooth, uninterrupted piece of beautiful open-pore wood or brushed aluminum. No visible buttons.
Very premium.
But underneath the surface, there are piezoelectric actuators. When you press firmly on a specific illuminated icon on the wood, the actuator fires and creates a sharp, highly localized mechanical click right against your finger.
So it artificially simulates the feeling of a button press.
Yes. It feels exactly mechanically identical to pressing a high-quality physical switch. It provides that essential tactile confirmation to your brain without requiring you to look away from the road.
That is fascinating. It perfectly bridges the gap between the ultra-clean digital aesthetic that designers demand and the absolute physical safety that human biology requires.
It really is the perfect compromise.
So, stepping back and looking at this whole MEC structure, we've really come full circle here.
We have covered a lot of ground.
We started way down at the foundation with the raw, liquid-cooled, unified superbrain hardware in Section 8.1.
The cross-domain's so key.
We moved up through the highly connected, actively monetized productivity ecosystem in Section 8.2, where your car is practically your office and your wallet.
The recurring revenue engine.
And we ended at the surface, the HMI, in Section 8.3. An interface powered by intent-based AI that deeply understands your stress levels, but still intuitively provides you the satisfying, safe mechanical click of a physical button when you actually need it.
That holistic synthesis right there, that is the true definition of the 2026 smart cockpit. It is an absolute triumph of systems integration.
It really is. It seamlessly merges the immense processing power of a server farm, the flexible ecosystem of a modern smartphone, and the intuitive, contextual understanding of a human companion.
And for you listening, the core so what of this entire deep dive is massive. Your vehicle is rapidly evolving to become the single most sophisticated, complex piece of technology you own.
More complex than the laptop on your desk.
Far more. It is going to understand your habits and your biometrics better than your phone ever could.
And for the broader automotive industry, the strategic implication is clear. The central battleground has permanently shifted.
Permanently. It is no longer about who can forge the best V8 engine block or who has the softest Italian leather.
It is a war of computing power, software architecture, and user experience. If an automaker cannot successfully build this compelling third living space, they are no longer selling a premium product. They are just selling a low-margin commodity.
They're just selling a dumb metal box with wheels, and in 2026, that is a recipe for bankruptcy.
It is a brave, complicated new world for mobility. But as we wrap up this analysis, I actually want to leave you, listener, with a final thought, a bit of a provocation to chew on as you drive today.
Go for it.
We have spent an hour dissecting the marvels of agentic AI. We have praised high-resolution infrared cameras constantly tracking your pupil dilation and your micro-expressions. We have marveled at a vehicle that intrinsically knows your daily schedule, actively listens to your private office meetings, and actively monitors your physical stress levels.
It is an incredible amount of personal data.
It is. We are rapidly entering an era where the machine parked in your garage literally knows more about your daily emotional state and your habits than perhaps your closest friends or your spouse do.
It knows your exact location, your biometrics, your financial credentials.
Exactly. So the ultimate question isn't whether the technology will work. The question is, are we, as a society, truly ready to trust a massive corporate machine with that profound level of personal intimacy simply in exchange for the convenience of this third living space experience?
We are fundamentally trading deep psychological privacy for unprecedented convenience on a scale we have never encountered before.
It is the defining trade-off of the next decade of mobility. Thanks for joining us for this deep dive. Drive safe out there and maybe take a moment to have a little chat with your car today. We will catch you on the next one.